Hi guys, it's Dr. Justin Southey here, going through some of the questions to help you with your tutorial assignment. And we asked you how to use the chain rule to find the indicated partial derivatives. So here's a function m, which is a function of x, y, and z, and we're told that x, y, and z are all functions of u and v, and we're asked to find a partial derivative with respect to u, with respect to e, at a particular point when u is equal to 3 and v is equal to -1. So the first thing we're going to do is we're going to work out values for x, y, and z when u is equal to 3 and -1. So I'm just going to do that on the side here. So when u is equal to 3 and v is equal to -1, well then x is equal to 2uv, 2 times 3 times -1 is equal to -6. Y is equal to u minus v, so that's going to be 3 minus -1, that's equal to 4, and z is equal to u plus v, that's going to be 3 plus -1, which of course is 2. Alright, that's going to save us a little bit of time substituting later on. Now, we've got the chain rule. This is the chain rule for functions of more than one variable, so we're going to use a little tree diagram. M is a function of x, y, and z, so that's got 3 lines coming out of it here. M is a function of x, y, and z, and each of x, y, and z are functions of u and v. So x is a function of u and v, y is a function of u and v, and z is a function of u and v. It's always helpful to start these questions by drawing your tree diagram. And we're asked to find, first of all, this partial derivative of m with respect to u. I'm going to jump straight in and use the nice shorter notation where we say the derivative of m with respect to u, we write m subscript u, and that's equal to, well, going to our tree, it's all of the ways that we can get from m to u. So the first way is we can go along this chain here via x. So that gives us the derivative of m with respect to x, m subscript x, multiplied by the derivative of partial derivative of x with respect to u. So multiplied by x with respect to u, plus, what other chains are there? Well, we could also get to u down here via y. So that gives us the partial derivative of m with respect to y multiplied by the partial derivative of y with respect to u, plus finally our last chain we could go along the right hand side here down to u, and we get the partial derivative of m with respect to z times the partial derivative of z with respect to u. Okay, now we need to work out what all of these things are, and that's quite easy because we've got all the functions over here. The partial derivative of m with respect to x, well, we treat everything else as a constant, so it's a constant multiplied by x. The derivative of that is simply the constant. In this case the constant is e to the y minus z squared, and we're going to multiply that by the derivative of x with respect to u. Now we're treating v as a constant, so the derivative there is simply 2v. Right, so that's this first thing over here, plus the derivative of m with respect to y. Now it's a little bit more interesting because we've got e to the power of a function of y. We're treating x and z as constants, so this is equal to x times e to the power of y minus z squared, chain rule, we keep the inner function untouched, multiplied by the derivative of the inner function. Well, we're differentiating with respect to y, so the derivative there is going to be 1 from the y, and this is a constant 1 minus 0. So that's just multiplied by 1. So that's m subscript y. Now we need to multiply by y subscript u. Differentiate y with respect to u. Well, the derivative there is 1 and the derivative there is 0. Remember, v is just a constant. So the y subscript u is simply 1. Plus our last term over here, derivative of m with respect to z. This is the most interesting one. Here we've got a constant times e to the power of a function of z. So we differentiate the outer function and we just get the constant times e to the power of the function untouched. Now we multiply by the derivative of the inner function. Now we're differentiating with respect to z, so the derivative of the inner function is minus it's minus 2z, not zz, minus 2z, and finally we multiply by the derivative of z with respect to u, which is just 1. Let's just put this in a little box. Alright, now, sorry, I got a little bit messy here, but this is a minus 2z. Let's simplify this a little bit before we go and substitute in. You'll notice that they've all got this e to the power of. So let's factorize out the e to the power of y minus z squared. And we're left with here a 2v. In the middle, we're left with a plus x. And here at the end, we're left with a minus 2 times x, and there's also z there, minus 2x z. Okay, so that's the partial derivative of m with respect to u. Of course, we don't just want the partial derivative, we want it at an actual point, we want a value. So when u equals 3 and v equals minus 1, we get the partial derivative with respect to u is equal to, substitute in, e to the power of y. Well, y we worked out at 3 minus 1, we worked out to be 4. So that's 4 minus z squared. Z is 2, so 4 minus 4. That's quite nice, e to the power of 0. Multiplied into 2 times v. Well, v is minus 1. Plus x, which we worked out to be minus 6. Minus 2 times x, again is minus 6, times z, we worked out to be 2. And that's equal to, well, this is e to the 0, so that's 1. That disappears. 2 times, we've got minus 2, minus 6. Minus 2 times this is 12, so plus 24. So that's equal to 24 minus 8 is 16. So that's the partial derivative at the point u is equal to 3 and v is equal to 1. Right, that's half the question. We found this one over here. We now also need to find this one. But it's exactly the same process. You just follow the 3 different paths, and I will let you try that one. If you struggle with it, please come and see one of us in the consultation times.